Welcome to the DIY Honda Garage channel. The DTC P0191 indicates an issue with the fuel rail pressure sensor, which is vital for monitoring the pressure of the fuel in the rail. This sensor communicates with the Powertrain Control Module, PCM, and is responsible for delivering accurate fuel pressure data to ensure optimal engine performance. When the output voltage of this sensor falls outside a specified range, the PCM registers an abnormality and logs the DTC. This situation can lead to engine performance issues and requires immediate attention. Understanding the integral role of the fuel rail pressure sensor, its location in the engine compartment, and its wiring is essential in diagnosing the problem efficiently. The fuel rail pressure sensor is a critical component that monitors the fuel pressure within the fuel rail of the engine. Its primary role is to ensure that the fuel delivery system maintains optimal pressure, which is essential for efficient combustion and engine performance. The sensor is usually integrated into the fuel rail assembly, allowing it to measure the pressure directly as fuel flows through. It communicates directly with the PCM, relaying vital information about fuel pressure that the engine requires for various operating conditions. If this sensor outputs a voltage that is either too low or too high, the PCM will conclude that there is a malfunction and store the DTC P0191, indicating an issue that must be addressed. Several factors could lead to DTC P0191 being logged. First and foremost, a faulty fuel rail pressure sensor can provide inaccurate readings or fail entirely, causing the PCM to detect an out-of-range condition. Secondly, wiring issues can significantly affect the sensor's performance, especially if there are open or short circuits within the wiring harness that connects the sensor to the PCM. These wiring problems might include damaged insulation or corroded connectors that disrupt the communication flow. Lastly, a malfunctioning PCM could contribute to this issue by misinterpreting healthy signals or failing to process input correctly from the fuel rail pressure sensor. Thorough inspections of each of these components are essential to accurately diagnose the issue. The symptoms associated with DTC P0191 include poor engine performance, which can manifest as sluggish acceleration or reduced power output during driving. This occurs because the PCM lacks accurate fuel pressure data to make necessary adjustments for optimal fuel-air mixture. Increased fuel consumption may also be noticeable as the engine struggles to maintain the optimal pressure, potentially leading to a rich fuel mixture. In severe cases, you might experience engine stalling or hesitation, particularly under load or acceleration. Recognizing these symptoms can prompt timely intervention to prevent further damage or performance degradation. For the first troubleshooting step of DTC P0191, start by turning the vehicle ignition to the on mode and allow the system to stabilize for about 2 seconds. This step is crucial as it prepares the vehicle's onboard diagnostic system to function correctly. Next, using the Honda Diagnostic System, HDS, check the reading for the fuel pressure converted from PF sensor voltage. If this reading is less than 0.28 volt or greater than 3.97 volt, it confirms that an abnormal condition exists, indicating that either the sensor or the associated circuits should be inspected further. If the values fall within this range, the fault may not lie solely with the fuel rail pressure sensor. In the second troubleshooting step for DTC P0191, begin by ensuring that the fuel rail pressure sensor connector, 3P, is disconnected. This action is essential for safely testing the sensor's performance without any electrical interference. Next, use a jumper wire to connect terminals number 1 and number 2 of the fuel rail pressure sensor connector. Once this is done, turn the vehicle ignition back to the on mode. The goal here is to confirm the HDS reading for fuel pressure converted from PF sensor voltage. The expected value during this test should be less than 3.97 volts. If the reading is within this range, it suggests a potential fault in the fuel rail pressure sensor itself. Otherwise, further investigation into related components may be necessary. In the third step for troubleshooting DTC P0191, comprehensive circuit inspection is required. Begin by ensuring the fuel rail pressure sensor connector is still disconnected, along with the PCM connector. This step will enhance the accuracy of your circuit tests. Begin assessing the wiring between the fuel rail pressure sensor and PCM for open wires or short circuits. Each of the circuit components must be checked according to specifications, such as measuring the VCC1 wire for excessive resistance. You should observe less than 1 ohm for normal conditions. If the conditions are abnormal, such as more than 1 megaohm for PF shorted to ground inspections, it indicates significant issues in the wiring that could be causing signal disruptions to the PCM. Finally, for the last troubleshooting step regarding DTC P0191, inspect the PCM itself to determine if it is functioning correctly. If the previous tests indicated that the fuel rail pressure sensor and the wiring are in good condition, it implies that the remaining suspect is the PCM. Conduct a deeper analysis and visual check of the PCM for any signs of damage or wear. Additionally, variables such as moisture, corrosion, or overheating should be taken into account, as these can adversely affect the PCM's performance. If it is confirmed that the PCM is at fault, it will require either repair or complete replacement to resolve the issue. After completing the necessary repairs indicated in the troubleshooting steps for DTC P0191, it is crucial to conduct a final repair verification. First, ensure that all replaced components, such as the fuel rail pressure sensor or any wiring, have been installed correctly and securely. Next, reconnect the fuel rail pressure sensor and PCM. Then conduct a retest of the fuel pressure readings using the HDS tool to confirm that the sensor is now functioning within the specified voltage range. If all results are as expected, it verifies that the repairs have been successful and helps prevent future issues related to fuel pressure monitoring. Preventive maintenance is key to avoiding issues like DTC P0191 in the future. Set a schedule for regular inspections of the fuel system components, including the fuel rail pressure sensor and its associated wiring. Keeping the wiring connections clean and free from corrosion can significantly reduce the risk of faults. Additionally, ensure that the fuel pressure sensor is not exposed to extreme temperatures and that the fuel system is free of debris or contaminants. Regular inspections and maintenance can lead to early detection of failures before they escalate into more severe issues, which helps maintain optimal engine performance. In conclusion, understanding DTC P0191 is vital for addressing fuel rail pressure sensor issues effectively. By recognizing the symptoms, such as poor engine performance, increased fuel consumption, and potential stalling, technicians can respond promptly to these warnings. Following a structured troubleshooting process helps ensure that all potential faults, from the sensor to the PCM, are methodically assessed. Finally, implementing regular maintenance practices can prevent similar issues from arising in the future, safeguarding the vehicle's performance and reliability. Remember that each component in the fuel delivery system plays a crucial role, and proper diagnosing and repairing these components can mitigate the risks of continued engine issues. Please like and subscribe to the channel. See you next time!